you can only make as much of a product as your limiting reagent will allow because it controls how much is actually formed. When it runs out, your process is done. It will stop. It's also completely consumed in the reactant. Guys, it's completely consumed. And this is the things you need to commit to memory, the concepts behind it. I know you guys can do the math. You showed me the math on Friday's quiz. But the concepts, this is where people struggle. This is what we've been building up to. These limiting and excess reagent problems are long. Right? They're tedious. And you're going to see why. We're going to be doing 2 or potentially 3 different 3-step conversions to figure these out. All right? It's the one that runs out first. So kind of the classic example, you guys did this with nuts and bolts on Friday. All right? But if we had 300 people and 250 seats, which is our limiting reactant? The seats, right? Because they're going to run out first. All right? The seats would be the limiting factor. So that's identifying our limiting reactant. Now, we also have this thing called excess reactant, and we're going to get into that today as well. If we're using this example of people on a plane, what's my excess reactant? What's my excess piece? The people, right? These are my excess. How would we calculate how much is left over? Right, we're going to subtract 300 minus 250. We have 50 people left over. There's our excess. So we all can kind of agree, right, that subtraction is going to be involved. But once we get to, it's getting to the point of being able to subtract, that's the difficult piece. That's the long process that it takes. Okay? With me so far? Pretty basic. We kind of saw this from the lab on Friday. Right? When one piece ran out, that's when it stopped being able to be made. All right, so let's kind of jump into an actual problem here. All right? So, when we're identifying limiting reagent, what we're going to do, guys, we're going to do a gram-to-gram calculation for all the reactants. So if we have 2 reactants, we're going to do 2 gram-to-gram problems. If we have 3 reactants, we will have 3 separate gram-to-gram problems. There's only one type of reaction that we could have where there's only one reactant. Does anybody remember what that is? Prize question. What type of reaction only has one reactant? Decomposition is what it is, right? Synthesis is one product, decomposition one reaction. So let me just say this. Do you think you're ever going to have a decomposition reaction in one of these? No, that's way too easy, all right? Typically, guys, they will be double replacement reactions or synthesis reactions, and that's what we're going to kind of look at here. So, whichever, here's the piece we got to remember. Whichever reactant produces the least amount of product, that is our limiting reagent. Okay? It's whichever one produces the least amount of product, that's our limiting reagent. Okay? So, here we go. We have 2 givens now, guys, in this problem. This is why you've got to keep them separated. All your units, not just grams, not just moles, it's the substance with it as well. Otherwise, it will get confusing very quickly. So, what's one of my givens I have in this problem? 5 grams of hydrogen and 5 grams of oxygen. They produce what? Water. Now, what are we missing? Before we can jump in and start doing some stoichiometry, what are we missing? We have to have a balanced equation, guys. So this is where you will have to write it yourselves. What are my reactants? Hydrogen and oxygen. All right, so tell me how to write them. Why is it H2? Diatomic, guys, part of Brinkelhoff. This is where it comes in handy. You've got to remember Brinkelhoff. All right. Then, what is it producing? All right. Water. Are we done here? What do we have to do? Balance it. How do we balance this equation? Just like that? Absolutely. So there's our balanced equation, guys. So now we have 2 givens. We're going from hydrogen to water. We're also going from oxygen to water. All right, so here we go. I've got 5 grams of hydrogen. I've got 5 grams of oxygen. Go ahead and take the next couple minutes, guys. It's a 3-step problem because we're going grams to grams. When it says how much, we are looking for grams. So go ahead and do that right now. Okay? If we looked at hydrogen, hydrogen could produce up to 45 grams of water. but it's not going to be able to produce this much because oxygen ran out first, right? We can only produce at most 5.63 grams of water because our oxygen ran out. We can't go beyond that. Once something runs out, you're done. Your process is over. Right? This is a great example why I've tried to tell you guys all year long. We can't compare grams of different substances to grams of different substances because their masses are different. We started with the same mass amount of each element here. But we know hydrogen is a whole lot lighter than oxygen. There are way more atoms of hydrogen and molecules of hydrogen in 5 grams than there are in 5 grams of oxygen. All right, this shows that grams can't be compared directly, which is why moles. That's why we use moles. All right. So as you do limiting reactant, the process, we go through it 2 separate times of the gram to grams, and then it's understanding what am I looking at. All right, looking at the data that we get, and then making our conclusions from there. And that's where knowing the concepts. That limiting reactant runs out first. It's the least amount that is produced. That's the big idea that you've got to keep in mind as you're doing these practice problems. Questions? All right. We're not going to do, I've already kind of did those on that slide. We're going to skip over that practice right now. We're going to talk about excess reactant. All right, because we're going to get more practice here as we go throughout the day today with limiting reactant by doing these excess reactant problems. And I'll be honest, folks, these ones, there's a lot going on. Okay, so these are going to be a lot. So if you want to use a separate sheet of paper, I would encourage it. All right, instead of trying to just squeeze it in a little space. But here we go. Excess reactant, guys. Excess just means what? Leftover or extra, right? Okay. So be looking for those key words in a problem. We've already seen example problems where we have that term excess in there. I think there was a problem on your homework last week on page 9 or 10 where it said something like, okay, you had 5 grams of silver chloride reacting with excess sulfuric acid or something like that. And everyone's like, well, what does excess mean? Here we go, guys. Excess is what's left over. That means that's not going to run out. Your limiting reactant will run out first. So the piece that you were reacting with in that problem was your limiting reactant. Here's how we do it. We're going to do gram-to-gram problems. We got to first find our limiting reactant. Then, once we find our limiting reactant, we're using that to calculate the excess reactant that's used. And how do we do that? That's this process right here. So we're going to break it up into steps today, guys. Okay? This first example, we're going to just do our limiting reactant like we just did. Then we will talk about the excess after it. So here's the problem. It says 15 grams of salt, NaCl, reacts with 20 grams of silver nitrate. How much AgCl is formed? What is the limiting reagent? Both of these will go together. And then we will do part C together in a few minutes. What's the first thing we need? Balanced equation, right? So we're given 2 reactants, guys. You have to predict the products. So here we go. Let's take a look at this. NaCl plus silver nitrate. What is silver nitrate's formula? AgNO3 is the correct formula. But again, they're giving you names. You have to come up with the formulas. Then we got to predict our products. What type of reaction is this? Just by looking at that. What do I have there? It's a double, right? Because I have 2 compounds. Good. So guys, this was that one, right? The square dancing with the partners. So whether you draw the lines like I encourage you guys to do, okay, split them up into your cation and your anion, right? The outsides are going to go together, and then the insides will now go together. Will they have the same subscripts necessarily on the other side? No, not necessarily. What method do we have to use? Crisscross method. Now, for the sake of time, guys, these ones, notice, do we see any subscripts anywhere along here? No. So we know that sodium's a +1, chlorine's a -1. Silver is part of that mini staircase. It's a +1. Nitrate, so they're all going to have the same substance on the other side. Your products then are going to be this right here. Silver chloride and sodium nitrate. Notice, they told you AgCl is formed, guys. They gave you one of your products right there in the question itself. All right, so you can always check that. So here's your equation. Go ahead. You're going to do the 2 gram-to-gram problems. You're going to figure out the limiting reactant and then how much silver chloride is produced. What do you notice, though, last thing before you guys go? What's different about this reaction versus the last one we had? Specifically, the number of products. How many did we have in the last one? 1. How many do we have here? 2. So, guys, when they give you when it's a reaction that has more than one product, okay, it doesn't matter which one you go to per se, but you have to go to the same one with your reactants, right? So we have 15 grams of sodium chloride and 20 grams of silver nitrate. Whichever, we can't just convert this to this one and then this to this one. They have to be converted to the same product, or else we can't compare them. Otherwise, it's like comparing apples and oranges. Now, in this problem, it told us to go to which one? Which one did it tell us to go to? Silver chloride, because it says back here, how much AgCl is formed. So you may as well just calculate that right there. So go ahead and do that, guys. So once you go through and you've done all of this math, how do we know which one's the limiting reactant? The least amount. All right? So that's going to be this one right here. So that answers both of our questions that we had to back here. How much silver chloride can be formed? That's 16.86 grams. It's the least. Now, which was our limiting reactant, though? It's not AgCl. I see so many people on tests, they put whatever they see there as their last unit. That's a product, though, guys. That's not a reactant. It's got to go back here to the beginning of your T-chart. Silver nitrate is the limiting reactant. Okay? So, we're looking for the excess throughout the whole thing. But in order for us to figure out the excess reactant, we have to understand and identify our limiting first. That's what we've done. So if silver nitrate is my limiting reactant, what's my excess reactant? Nope, just what is it? What is the reactant, guys? It's excess. Sodium chloride, right? It's the other reactant. We said that this is my LR, so that makes this the ER, the excess reactant. All right? Does that make sense? Now, we can't just subtract something yet, because we have nothing to subtract. We need to figure out how much excess reagent is left over, not how much we had to begin with. So if we go back here, guys, what we're going to do is we're going to do another gram-to-gram problem. All right? We're going to start with our limiting reactant, though, starting mass, and we're going to convert that to our excess reactant, because we use up all of our limiting reactant. How much do we have of our limiting reactant here? Nope, not 16.86. 20, right? We have to go back to the original problem, guys. We had 20 grams of silver nitrate to start with. All of that is completely consumed in this problem. It's all used up. So what we're going to do is we're going to take that amount, and we're going to see, okay, how much of our other reactant did it require to completely consume 20 grams of silver nitrate? So we're going to convert this number to grams of sodium chloride. So go ahead and do that next step right now. So guys, when you do this out, you get about 6.9 grams of sodium chloride. So what this is telling us, by us going from silver nitrate, which was the limiting reactant, and us converting to the other reactant, which is our excess, what this is showing, guys, that for 20 grams of silver nitrate to be used up, it only took 6.9 grams of sodium chloride to react with that 20 grams to produce that 16.86 grams of silver chloride in the end. Okay? So that means we had a lot more than that, right? How much sodium chloride did we start out with? 15, right? So we had a lot more. We started with 15 grams. That's kind of our initial. And I can't spell today. Okay? But we want to figure out our final of how much we had left over, or our excess. How do we do that, do you think? Subtract, right? It's a simple subtraction problem at this point, 6.9 grams. Subtract them out, what do we get? .1 grams. All right? We have to go through all of that other work to get to the simple part, guys, of subtracting. All right? But the math is nothing new. We've done gram-to-gram problems now for a week and a half. Okay? It's the process of understanding what I'm looking at. And you have to know your concepts, guys, the background information of what a limiting reactant is and what the excess means in order to be able to solve this. All right? Questions on this problem? All right. There's a practice problem that's in your notes. First things first, we need an equation. We're given. It's the next page, I'm sorry, page 7 at the top. Guys, we're given our reactants. We've got KOH. And we have aluminum nitrate. Take the next minute or so and try to predict your products. So, when you go through and do all the math, folks, based on our equation that we had, where we predicted the products, all right, you should end up with 23.42 grams of potassium nitrate from KOH. And then this is aluminum nitrate down here. Questions on how I got any of those? Excuse me. So our molar mass of aluminum nitrate was 213. Did you have that as your molar mass for aluminum nitrate? Remember, guys, when you're calculating molar mass, the 3 on the outside of the parentheses gets distributed into each of them on the inside. Now, if you made that mistake, guys, 1, on a test, I'm going to give you most of the molar masses, so don't worry about that. 2, if you were to make a mistake and you show everything else based on that and carry even your mistake on from there, based on it, you're still going to get most of the credit. You're going to lose 1 point. This would be like a 10-point problem or even more, or even a 12-point problem. You're only going to lose 1 point on that. Like I said, on your test, I'm going to give you the molar masses. So if you did everything else correctly based on that, guys, you know the process, all right? Don't get hung up on that molar mass piece. So with these two answers here, what you should get, okay, which is my limiting reactant? Which is the limiting, which one? So how do we identify that? How do we identify the limiting reactant? The smaller. Which one produces the smaller? So there's the smaller amount, which means this reactant, guys, KOH, is my limiting reagent. And how much was produced? 23.42 grams. You with me? Give me a thumbs up, guys, if you got that completely correct. Give me a side if you were on the right track, but maybe wrong molar mass or something like that. Okay? Give me a thumbs down if you have absolutely no idea what we're talking about at all. Okay? So now, from here, guys, the part C, it says how much of the excess reactant is left over. What do we have to do with that? We have to go back to our original amount of our starting material. And then we're going to convert that through to the other reactant, which is AlNO3. All right, so this is the process then that we would go to. All right, so in the end, converting from potassium hydroxide to aluminum nitrate, they will take up 16.45 grams. What's the very last step once we get here? That's when we have to subtract. We have to look and see, okay, this is how many grams of aluminum nitrate I have that are consumed. How many did I have to start with? Well, I had 17 grams. So to figure out my excess reagent left over, 17 grams minus 16.45, 0.55 grams excess is what we should end up with. What's that? Absolutely, I'm going to leave it up there.